Hey guys, it's Lexi, and in this video on alkene reactions, we'll be summarizing the 3 hydration reactions. So there are 3 types of hydration reactions that we talked about. There's acid-catalyzed hydration, oxymercuration-demercuration, and hydroboration-oxidation. And one difference to consider between these 3 reactions is their regioselectivity. So I've listed the reagents that are used for each of these reactions just as a reminder to you, and I've also listed the regioselectivity. So both acid-catalyzed hydration and oxymercuration-demercuration are Markovnikov reactions, meaning that the OH group is adding to the more substituted side, and the hydrogen is adding to whichever side has more hydrogens, which is also known as the less substituted side. And then for hydroboration-oxidation, it's kind of the exception. It is the one where we're going to add the hydrogen to where there are less hydrogens, meaning it's going to the more substituted side. And the OH group is adding to the less substituted side. So hydroboration-oxidation really stands out from the other 2 due to its regioselectivity. With that said, then you might wonder, well, if oxymercuration-demercuration and acid-catalyzed hydration both add the OH to the more substituted carbon, why would I ever use one over the other? And the difference comes in understanding the intermediate. Remember, acid-catalyzed hydration has a carbocation intermediate, meaning it is susceptible to carbocation rearrangements. So if you're trying to add an OH group to the more substituted carbon, but you do not want it to rearrange, you would have to do oxymercuration-demercuration. Whereas if you're adding the OH group and you do want a rearrangement to occur, it would be acid-catalyzed hydration. So you just want to be aware that acid-catalyzed hydration is susceptible to carbocation rearrangements, whereas oxymercuration-demercuration is not, because the intermediate is not a carbocation, but rather a mercurinium ion. Finally, the last point of comparison is stereochemistry. The intermediate, like we said, for acid-catalyzed hydration is a carbocation. Remember, a carbocation is like a piece of paper. It's flat, sp2 hybridized, trigonal planar geometry, meaning 50% of the time it can get attacked on the top face and 50% of the time on the bottom face. So if we're forming a new chiral center, we're going to get 50% R and 50% S at that chiral center. For oxymercuration-demercuration, we said the intermediate is that cyclic mercurinium ion. And remember, when you have a cyclic intermediate, that's going to result in anti-stereochemistry. So oxymercuration-demercuration is going to have the H and the OH add opposite to each other, meaning one on a wedge and one on a dash. And then for hydroboration-oxidation, we talked about how the reaction is concerted, meaning the BH2 and the H add at the same time on the same face of the double bond. This results in syn stereochemistry. So at the end of the reaction, the H and the OH are both adding on a wedge, or they're both adding on a dash. Thanks for watching. If you have any questions, feel free to leave them in the comments below. If you enjoyed the video, make sure to give it a thumbs up, subscribe, and also hit the notification bell so that you can stay up to date when I upload new videos.